This is a continuation of the three-phase motor series that we've been doing. Been having lots of discussions or various comments, and it's been quite interesting, and some of the things that I thought I was dead sure of, sort of you go, maybe this guy's got a point, let's investigate a bit further. So this is what this is about. What we've got here is a small three-phase motor on a gearbox, so there's a bit of drag to the starting of it. This brings me in mind when I had a huge Denby pillar drill, flat belt drive, and it had a 3 horsepower three-phase motor on it, and we had to use a run capacitor, run it on single phase with a run capacitor and a start capacitor with just a button. Just press the button, pull the start capacitor in. But what I'm going to do here is not only talk about the wiring and measure the voltage. One of the comments was about capacitor voltage. So I've been messing about down here with capacitors, and we can measure the voltage across them. Another thing is, this is different wiring, so we've got an explanation of that. And the third thing would be, one of the comments was we've dropped a phase, so I'm going to talk about that and we'll do an experiment. Let's get on with it. Right, let's start at the beginning. I took this cover off, and all we've got is a connector block. There are no two parallel lines of connectors with the fish plates between and whatnot. So there's just A1, A2, B1, B2, C1, C2. Okay, so let's just talk about that for a minute. This is how it was wired when I took it off. The motor plate said 440 or 240. Okay, so but it was wired for 440, so what we've got is A1, B1 and C1 all connected together. Where's my pen gone? Here it is. So if A1, B1 and C1 are connected together, then we've got star with the red, the blue and the yellow going into there, there and there. So I had to think about this for a short while, and I thought, alright, okay, that makes sense. So I took those links out and put these links in. A1 to C2, through the coil to C1, then a link to B2, through the coil to B1, then B1 a link to A2, through the coil to A1. So what we've got now is delta. There's the coils, and this is, I'm not going to write this, that's A1 and C2, because there it's linked through. That one is A2 and B1, again because there's a link, and that one is B2 to C1. So hopefully that makes sense. So when you take a motor plate off and it's not what you expect, then just have a look and think. Go back to basics and go, how have they wired this? There was another motor I looked at a while ago, and all it had was 3 connections with the blue, red and yellow going to it, and then a further connection. And when I investigated, these had got the 3 wires in, and they've got 3 wires going to the motor, and this one had got 3 wires going to it. So when you think about it, again, it's the same as that. It's wired in star. That'll do. So what we've got here is, I've wired it in delta, and I've brought the wires out, and I've kept the colours just to make it easy. You may notice I put an earth on it. Not that it needs it in this experiment, but let's do it anyway. So coming down here, what we've got, this black wire here is the mains input. So we've got to be a bit careful because we're dealing with mains power, 240 volts. So the brown goes to the red. The blue, which is the neutral, goes to the blue. And then the yellow we're going to use as the capacitor. So let's pull some wires out. And poke some wires in. I think we might be better off just nipping that up. So we're taking the capacitor from the neutral, as in there, from the neutral through the capacitor to there. Okay, if you took it from the live, the motor would go the other way round. Hopefully that makes some sense. I've got the meter set up with my trusty golden syrup tin, which is absolutely brilliant for upside down pudding and rice pudding. And those of you who don't know what upside down pudding is, you put pineapple in the bottom of the dish with some golden syrup and then a sponge mix on top and bang it in the oven. And then when you bring it out, you turn it upside down and the pineapple's on the top. Right, let's have a look. Are we there? We've got one capacitor across there and it's an 8 microfarad. So let's see what happens. Contact. Switch the meter on. I'm going to see if I can see that. So we go from there. It's set on 700 volts AC. We go from there to the live, and that shows 241 volts. We'll go across the live and neutral. 233. We'll go across there and there. That shows 266 volts. 267 volts. Right. That's an 8 microfarad one. This one is a 5.5. This has got solid wires, so we may be able to just poke those in there. For experimental purposes only, you understand. Contact. Still starting alright. $234, 208. Let's move this round here. Quick cup of tea. You may notice I've lost my other cup. I think I put it on the spare wheel of my motor and then drove off. It was a sad loss. Right, so you can see that if you put too much capacitance on, then the volts go up, and of course the coils in this motor, because we've changed it to 240 volt operation, when you start putting 260, 280, 300 volts in there, of course the coils will get warm. So that was interesting, and I can't remember the guy's name who emailed me about that, but he's got a video on there it's showing start capacitors and measuring the voltage. So thank you very much for that. It's much appreciated. You know, it was just the idea, well, measure it. It's not rocket science, but you've got to think about it. Right, what we've done now is we've got an 8 and a 5.5. So we'll just give that a go. The motor is a bit noisier. $299, 290. So that's obviously not a good thing. Okay, so we could. Where are we? Stay there, you. It's going for a walk. Right. So we might even get away with less than 5.5 microfarads. But that seems like it's all right. I've got the motor plate here. Let's see what that says. I need me better glasses on. So the motor plate goes 1400 revs, 0.4 of an amp. Why is there always a great big ding on the bit where you want to read it? It says horsepower. It's probably quarter horsepower. Can't really read it. Typical. Anyway, never mind. So it's quarter horsepower or less. So you don't need a huge capacitor, and we've just shown that if you put too much capacitance on, the motor will be a bit noisier and it will burn out because you're putting far too many volts through it. Right, the next thing of interest was the fact that are we running on 2 phases or 3 phases? So the capacitor, which is the yellow one, and the live goes to A1 and the neutral goes to B1. So live through that link, through the C1, C2 to the capacitor. It also goes through its coil to neutral. So if we got rid of the B2 to C1 link, it shouldn't make any difference. Right, we're making it up as we go along now. So let's see what happens. Everything is isolated. Let's get rid of that. Sit that up there like that. We've got the capacitor in place. Contact. Well, there you go. I need to find out a bit more about this. So, it's still started. So what we can do now, we've got that link missing. So, and it connects to B2. Okay, so I'm going to run it without the link. And then, oh yes. There's power going through there. So without that link there, it runs a lot slower. Now whether or not the motor would burn out running a lot slower, I don't know. But you connect it and you pick up speed. But once you picked up speed, if you connect it again, there's still a spark there. So power's still flowing through that link. So it looks like, although we think we've lost a phase, one of the phases is, all 3 phases are actually working. I would really appreciate comment back on this one from somebody who knows a bit more than me. But that experiment is quite useful. Hopefully everybody's gained a bit from this, and again, thank you very much for the contributors on feedback to the other videos.